question like this would be worth quite a few points because I'm asking you to do quite a few things with it. Part A, the possible zeros. You have to find your p's and your q's. P comes from the constant, and q is from the leading coefficient, and it's all the factors, everything that divides it evenly. These always have positive and negative, so everything that goes into 2 would be plus and minus 1, plus and minus 2. Everything that goes into q would be 1, 2, and 4. So the possible, you do p divided by q. So 1 over 1, and everything still gets a plus or minus. 1 over 2, 1 over 4. 2 over 1 is 2. 2 over 2 is 1, I already have it. 2 over 4 is 1/2, I already have it. So that's part A. I would expect you to list the p's, the q's, the possible zeros. Then I ask you to find all the real zeros. This is not something that I'm just wanting you to look at a graphing calculator and write them down. If you did part B and didn't show me work, you would lose a lot of points here. We used the graphing calculator to find 1 zero that worked. So these are the things that could work. We looked at our graphing calculator. Something that works would be an x-intercept. So you look at the graphing calculator to tell where it hits the x-axis. Should be one of those numbers up there. And you see it happens at +2. So what we did was synthetic division with a +2. So we put the 2 there and then all of our coefficients. So first number comes down, then it's a series of multiply and add. So 4 times 2 is 8, add and we get 4. 8, 1, 2, and 0. So that's 4x squared plus 4x plus 1. Then, once it's a quadratic, we can factor it nicely. So we could do box method here. So I need two things that multiply to 4 and add to 4. So that would be a 2 and a 2. So we get 2x and 1, 2x and 1. So the zeros. Two was a 0. The other one comes from this 2x plus 1. If you set 2x plus 1 equal to 0, you subtract your 1, divide by 2, you get -1/2. Now that one showed up twice, so what did we put with that? Multiplicity 2. C is the factored form. So this factored into, we had the 2x plus 1 squared. If 2 is a 0, what do I put in my factored form?
X minus 2.
Right. You have to be able to plug a 2 in for x and get 0 out. So that's our factored form. Any questions on that one?
How would you get 2 for a 0?
From my synthetic. We found that first 0 just by looking at the graph where it hit the x-axis. Other questions there? Okay. So number 2, this was the next piece we did at the beginning of the semester, was graphing the rational functions. And we had a series of steps that we did to graph those. So I would break it down like this on the final as well. I would tell you all the things that you need to do in order to get this graph. Again, these two questions are your high point value questions because there was a lot involved on those. So you definitely want to make sure you know what you're doing on those. So part A was factor. X squared, you could factor into x times x. If you leave it as x squared, that's fine. The denominator, we could do box method. Multiply to -6 and add to +1. Leave +3 and -2. Intercepts. This is back to your Algebra 1 days. What is an x-intercept? If it's on the x-axis, what do you know about your y value? It's 0. So you plug in a 0 for your y. You can do it in the factored or the original. What's going to happen is the first thing you would do is multiply by your denominator. And what's 0 times anything? So when we did these, we talked about the x-intercept is really what makes the top of the fraction equal 0. So if you square root, you get x equals 0. So we hit our x-axis at 0. Y-intercept is where you cross the y-axis, so that means x is equal to 0. So if you plug in a 0 for all of your x's, you get 0 over -6, which is 0. Alright, asymptotes. We need to review, we had those rules. Question number 25 on your study guide is just some more asymptote questions to help you review those rules. So a vertical asymptote is x equals whatever makes the bottom 0. So that's where that factored form is really, really useful. If I look at that, what would make x plus 3 equal 0? And what makes x plus 2 0? I don't have you find these just for fun. I expect you to graph them. So we have a dashed line at +2. Okay, then we have to look at horizontal or oblique. Oblique happens when the degree on top is 1 more than the bottom. Okay, this is x squared over x squared, so it's the same degree. If it's the same degree, how do we get the asymptote? Divide the leading coefficients. So 1x squared over 1x squared is just 1. So our horizontal is y equals 1. So if the degree on top was smaller, it was always 0. If it's the same, you divide the leading coefficients. And if it's 1 bigger, it's oblique. Then we use our graphing calculator to fill in the gaps. When you plug it in, I would use the original. Make sure you do parentheses around the denominator. And when you graph this, what I'm expecting, you are approaching your asymptote. So make sure you draw a curve that is getting closer to your asymptotes as time goes on. That's what their purpose is. It's a line that you are approaching. Is that okay? Let's jump to number 4. So a little more recent, solving all of these radical equations. What you have to remember on these, first step is always isolate the radical. So if I'm looking at this first problem, I need to get the radical by itself. So what do we do? Add our x. So we get the square root of 11 minus x equals 1 plus x. Then, to cancel a square root, we would square. Okay, on the left, the square root and the square drop. On the right, if you have 1 plus x squared, what do you have to do? FOIL. It means you have 2 of those. So you have 1 plus x and plus x, so that's plus 2x plus x squared. It's a quadratic, so we always set those equal to 0. So I have to add over my x, subtract my 11. Because it's a 1x squared, we can do the shortcut. So what multiplies to -10 and adds to +3? 5 and -2. Set each of those equal to 0, so x is a -5 and +2. But there's one other thing. On any of these problems, when we start squaring, what do we have to remember to do at the end? Check it, because we might get answers that don't work. So to check it, you plug it in the original. You are welcome to do that on your calculator. If I did the -5, I get the square root of 16, which is 4, plus 5. Does that equal 1? No, so that one doesn't work. When I check 2, I get square root of 9, so 3 minus 2 equals 1, and that does work. So the only answer that checked on this one was positive 2. So that's B. Okay, first step, isolate the radical. We have 2 of them, but there's only 1 on each side. How do you cancel a cube root? Cube it. So if I cube each side, those drop. It's a quadratic. What do we do with quadratics? Okay, so we would try our shortcut. Is there anything that multiplies negative 5 and adds positive 3? No. So that means we have to do quadratic formula. So opposite of b, be negative 3, plus and minus the square root of b squared minus 4ac all over 2a. We get negative 3 plus and minus the square root of 29 over 2. Technically, you should check these. You could always put those in your calculator and get a decimal and then just plug in the decimal. For the sake of time, I am not going to do that right now because I trust that you guys can plug something in on your calculator, but both of these do check out. Let's see. So there's a radical. First step is isolate it. So what should I do? Subtract our 5. Okay, then to get rid of a square root, we square. What am I going to have to do at the end then? Check. When I add that square, I know I need to check. So over here we get 3x plus 4. Over here, think of it as writing it twice and foiling, so you get 4x squared minus 8x and minus 8x, so minus 16x plus 16. It's a quadratic, so what do we have to do? So if I subtract over my 3x and subtract over my 4, we have a 4x squared and a 12. Those two things multiply to 48, and they need to add to negative 19. So what's that going to be? If we factor, we get 4x minus 3, x minus 4. So if you set each of those equal to 0, we get 3/4 and positive 4. But we know we have to check. Can I just tell you guys, because you guys can take a calculator and plug them in, right? You know how to do that? So when you check it, the 3/4 does not work, and 4 is our only answer. Were we okay with D on that? We didn't ask about it, but everybody okay with that one? Let's go to 7 and 8. So we got into the log stuff. When we have an equation with logs in it, our goal is to get rid of it. So start over here. You have 2 logs being subtracted. How can you combine those into one? Division. So it's log base 7 of 3x plus 2 over x minus 2 equals 1. So really, that's what you have to remember about these logs. If the logs are subtracted, you divide when you put them together. If the logs are added, we multiply. If there is a log on one side, then we use the definition, like you did on problem 5, to change it to an exponential. So what this means is 7 to the first power equals 3x plus 2 over x minus 2. 7 to the first is just 7. If I want to get rid of my fraction, I can multiply over my x minus 2. So I get 7x minus 14 equals 3x plus 2. Subtract my 3x, add my 14, and we get x equals 4. Again, with these logs, you should double check. Remember, when you put them in, the argument has to be positive. So if I put in a 4, 12 plus 2 is positive, 4 minus 2 is positive, so it's okay. You can never do the log of a negative number. And problem number 8. So this is kind of a step easier than the last problem. The last problem we had to start by combining logs. Here I'm starting with just one log. So if you have a log on one side, what do? Change it to exponential. So it's 6 to the 5x plus 3 power equals 36. How did we solve these problems? Common base. So 36 is 6 to the second. So then you can set your exponents equal. So if you subtract your 3, divide, you get negative 1/5. So if you have a problem with log, use the definition to get rid of it. Anything else on 1 through 9 that you want to talk about? So for tomorrow, I'd like you to do the next page front and back, so that's 10 through 21.